The Leaning Tower of Pisa is one of the most recognizable structures in the world. But it's not famous for its architectural beauty or its historical significance alone. It's famous because it leans. For centuries, this medieval bell tower has defied gravity, tilting at an angle that seemed to promise its imminent collapse. Before its stabilization, the top of the tower was displaced by a staggering 5.5 degrees, or about 4.5 meters from where it should have been. This precarious slant turned an architectural mistake into a global icon, drawing millions of visitors who came to marvel at the tower that just wouldn't fall. But this famous flaw was also a ticking clock, a structural problem that engineers wrestled with for generations. The story of the lean begins almost as soon as construction did, in 1173. The foundation sat on a dense, unstable mix of clay, sand, and shells, too soft for a marble tower. By the second floor, the south side had already begun to sink. As the weight pressed down unevenly, water was squeezed out of the clay, the ground compacted, and the foundation settled. This consolidation was stronger on one side than the other. Tilt initiated. A century-long pause let the soil gain strength, a lucky break. They compensated by making floors taller on the sinking side, giving a banana-like curve. As the tower's tilt became more alarming, so did the attempts to correct it. Engineers and architects proposed all sorts of solutions. Many made things worse. One of the earliest big interventions came in 1838. An architect ordered excavation of a walkway around the base to reveal carved foundations. They removed supporting soil and disturbed the water table. The pit flooded, and the tower lurched several centimeters in days. In 1934, engineers drilled hundreds of holes into the foundation and pumped in nearly 90 tons of grout. Forceful injection lifted the base unevenly, suddenly increasing the tilt. A harsh lesson in unintended consequences. Commissions grew cautious. Direct foundation work was avoided for decades. Engineers tried less invasive methods, over 600 tons of lead counterweights on the north. Like a seesaw, it slightly reduced tilt, but stressed the masonry. An engineering bandage, not a solution. Every failed attempt became data, pointing toward working with the soil, not against it. A more subtle, clever approach was needed. A minor quake or storm could have finished a 14,500-ton masterpiece. After decades of debate and failed experiments, a new international committee formed in 1990. They closed the tower to the public and embarked on an audacious plan to save it. The winning idea was championed by British engineer John Berlin. Not push or prop the tower, but coax it to lean back on its own. The method was under-excavation, removing small, precise amounts of soil under the north side. Like a toy block on damp clay, don't push it upright, scoop a little under the raised edge. It settles back, slowly, controllably. Now do it with a 14,500-ton medieval tower. First, they secured the tower with steel cables anchored to the ground, a safety net. Then, 41 angled hollow drills were installed under the north foundation. Over months, the augers rotated, pulling out small volumes of dense Pisan clay, 30 to 50 liters at a time. They monitored continuously with sensors, plumb lines, and GPS stations. As voids formed, the ground above subsided, and the tower began rotating back, movement measured in millimeters. By 2001, about 70 metric tons of soil had been removed, reducing the tilt by nearly half a meter, back to its early 1800s angle. The tower that had been on the verge of collapse was finally stable. The under-excavation project was a landmark in civil and geotechnical engineering. It saved a World Heritage Site and showed the power of soil mechanics. They didn't use brute force. They used finesse, creating conditions for the tower to heal itself. It was declared stable for at least the next 300 years. Crucially, they never intended to make it straight. Its lean is its identity. By reducing the tilt from 5.5 to about 4 degrees, they moved its center of gravity to safety. Stress on the southern foundation and masonry was relieved. Pisa pioneered precise soil extraction and real-time structural monitoring used on other heritage sites. It underscored a multidisciplinary approach: historical research, advanced modeling, incremental execution. Today it's a classic case study worldwide, solving the impossible with ingenuity and respect for the past. Today, tourists once again climb the 294 steps, confident in the science that keeps it standing. The project didn't just save a building, it preserved human history and a symbol of beautiful imperfection. Its clever solution became a celebrated chapter in engineering. Sometimes the most elegant solution isn't to add more, but to carefully take something away.